In the near future, automation will find its way into ever more areas of our life. Algorithms will steer vehicles, control power systems, and household appliances. Manufacturing is no exception. Already today, robots and machines position workpieces precisely for the next processing step, join components together, or even carry out specific processing steps. A fully automated manufacturing industry, or Industry 4.0, has been looming on the horizon for some time now. At the NCCR Automation, researchers are developing control strategies that prepare manufacturing robots for the future.
When you hear about robots, the common assumption is that they can only do one repetitive task. And we aim to change that by equipping them with various types of sensors, and this enables the use of intelligent predictive control algorithms. So we equip our robot with multiple sensors to very precisely measure its position. We use this stereo camera, and it measures the reflected light from these markers and also from those on the ground. And so then the robot knows its position with respect to the ground and also relative to its previous position. This information we pass to our algorithms. And then we would have additional sensor at the tool holder, which will allow to measure the forces applied during machining. There will be a machining tool here, and another sensor which is monitoring how the machining is going, the progress and the quality achieved during machining. And this will allow then adaptation during machining and achieving better results. And this project is done in collaboration with industrial partners.
These concepts can also be applied to other types of manufacturing processes.
So, selective laser melting is a 3D printing process where we use a laser to melt metal powder into a solid structure shape. First, a digital model of the part is sliced into very thin layers and then passed into the machine. And then in the machine, we have very fine metal powder here, and the metal powder is put on the build platform by using a slider arm. And a laser is melting the powder according to the part's layers information to generate its body in layers. So this cycle continues, recoating the powder and then exposing with the laser continues until the whole part structure is obtained. So the process has been gaining a lot of attention from various industries like aerospace, aviation, automotive, healthcare. The main advantage is the flexibility to manufacture very complex geometries, and also goes along with cost-efficient manufacturing, and also enables different materials to be used in application that hasn't been possible before. So as we speak now, there are parts flying in the aircraft engines up in the air, manufactured by this method specifically. So the manufacturing system is a complex system here. Different elements are working together to manufacture the parts. And this complexity brings concerns about robustness and also quality in the way of industrialization. So due to these high energy input coming from the laser into the powder and the parts, there are some undesired effects and undesired quality problems that we obtain in the end, such as parts are not being printed properly in the perfect geometry, or the material properties of the parts are not being ideal. So in the common practice, the parameters that are actually affecting the final quality of the part, such as the laser's power or moving speed, are optimized and fixed in advance. However, some conditions through the printing process are changing, such as the temperature buildup caused by the laser. And these changes are actually causing some defective parts in the end. In our system, we have multiple sensors that are actually sensing the process. We have an infrared camera, we have a high-speed camera, and we have other multiple temperature sensing instruments. So we are actually acquiring tons of data bit by bit through the process. And it is run through our algorithm to actually understand what's happening there, to identify the defects while they're happening, and correcting them on the fly. For high-quality demanding industries such as aviation and healthcare, it is very important to ensure the quality of the part in the end. With our project, by identifying and correct the defects that are happening during the process on the fly, we are decreasing the number of defective parts in the end. We are also enabling even ever higher, complexer parts to be manufactured this way, and also different and new materials to be processed.
So we hope to really increase the sustainability of manufacturing processes With these techniques, we are going to make it possible to produce single parts and not just batches. The controllers will make it possible to adapt to new requirements, and this will reduce waste. It will reduce the material, the energy use during manufacturing. The NCCR provides the ideal interdisciplinary environment for my research, and collaborations with top groups in computer science, in automation, in control. It really makes it possible with its support to do this research.